Welcome to the Walton Pi. Today we're going to be talking about derivatives at a point as well as how to calculate them. So the derivative of a function is a very special type of a limit that has a very useful interpretation. So the derivative represents the rate of change of a function. So there's a few different ways we could interpret this. We can think of the derivative of a function as the slope of the function at a given point, or sometimes it has a physical meaning, like the derivative of position is going to give us the velocity, or the derivative of velocity gives us acceleration. There's physical applications to a lot of these sorts of rates of changes, and so we are going to be using these quite a bit throughout all of calculus. So there's two different ways to state the definition of the derivative of a function f of x at a point a. So we can either write the derivative of f at a, so we're going to write the derivative of f as f prime. So f prime of a, or the derivative of f at a, is either equal to the limit as h goes to 0 of a plus h minus f of a all over h, or the limit as x goes to a of f of x minus f of a all over x minus a. Now, these might look different to you, but they actually represent the same thing. If we just let x be equal to a plus h, we see that they are actually going to give us the exact same value. And so that's why these two definitions are interchangeable. So we are now going to go through an example of each of these separately. So let's find the derivative of f of x equals x cubed minus 3x squared plus 2x at the number a. So let's use the first definition. So f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a all over h. So we are now going to plug in a plus h into f of x as well as a into f of x, and we'll just expand it all out. So that gives us this massive thing, a plus h all cubed minus 3 times a plus h squared plus 2 times a plus h minus a cubed minus 3a squared plus 2a all over h. What we're now going to do is we are going to expand out everything. So this is what that looks like when it's all expanded. This is a place where you have to be very careful not to make arithmetic errors because it's very easy to mess up somewhere. Now at this point, we are now going to try and hope that everything that does not have an h in it is going to cancel out. So if we go through and do that, we see that all of those terms are going to cancel out, and everything that's left has an h in it. And so if we then divide all of those h's out, this is what we are left with. It turns into the limit as h goes to 0 of 3a squared plus 3ah plus h squared minus 6a minus 3h plus 2. And the limit as h goes to 0, well, that's just 3a squared minus 6a plus 2. And so that's the derivative of f of x at the number a. Let's do the same exact thing, except we are going to use the other definition. So the limit as x goes to a of f of x minus f of a all over x minus a. Well, that's going to give us x cubed minus 3x squared plus 2x minus a cubed minus 3a squared plus 2a all over x minus a. So clumping terms that look similar, so we have x cubed minus a cubed minus 3 times x squared minus a squared plus 2 times x minus a. We now want to try and factor out an x minus a from every single term, and it turns out we can do that. We get x minus a times x squared plus a squared minus 3 times x minus a times x plus a plus 2 times x minus a. Again, we are going to be able to cancel an x minus a from every term, and so we're left with just the limit as x goes to a of x squared plus a squared minus 3 times x plus a plus 2, and that again also is going to give us 3a squared minus 6a plus 2. So you see, it doesn't matter which one you do, but they both are going to give us a valid answer. I hope this was helpful and that you're able to understand the idea of a derivative at a point a little bit better. Please like and subscribe if you haven't already so I can continue to make these and so you don't miss the next videos in this Calculus is a Piece of Pie series. I hope you all have a great rest of your day and good luck with the rest of your math.